So we're now going to continue, and now we're going to look at the relationship between quality and a variety of other parameters. So we're going to ask, is red or white wine higher quality? And what we do is here we group by color. So that takes all of the rows that are red and all of the rows that are white, and then it computes quality, looks at the quality column, and then computes the mean. So we see that the two are not very far apart, so that suggests that they're similar. We can get all of the statistics using describe. And so again, here we see mean is pretty close. Standard deviation is very large compared to the difference between those two. Min is identical, 25%, 50% identical, and max is different. So it's interesting to know that the best wine is actually a white wine. Okay. So the highest quality pH, let's see. Here is all of the pH using describe. So we have the quartiles here. So what we're going to do now is we're going to split the data set into quartiles. Okay. So here are the edges of the quartiles that I'm getting here directly from here. 2.72, 3.11, 3.21, 3.32, and 4.01. And then I just give them names. And then here we're using a new function, cut, which what it does is it splits the data set, the columns, along these bins. So it groups them. And then it's going to add this new column called acidity levels at the very end. So let's look at it, what it looks like here. So here, for example, the first one is bottom Q, and look at a pH is 3.51. So 3.51 is this one. So this corresponds to bottom Q, bottom quartile. Okay, and then what that allows us to do is to group everything by that, compute the quality, okay, and then we have the mean for each one of them, okay, and you'll just see that slightly different syntax. So here we had parentheses, square brackets. Here just parentheses will actually work. So just know that in this case, that slight change works. Sometimes making slight changes to code doesn't work, but here it does. Okay, and then here we get all the quartiles, so we can look at them. So means are very, very close together. The standard deviation is much greater than the difference in the means. The mins are the same, 25% the same, 50% the same, 75% the same. Okay, so again, nothing interesting with acidity levels. Okay, let's look at quality as a function of amount of alcohol. So we can look at the median of the alcohol. And we can look now at low alcohol and high alcohol. So low alcohol of 5.5, high alcohol 6.2. Okay, so now that actually looks interesting and might be worth exploring further. Okay, so quality as a function of sugar now. So let's look at low and high again. So we split it by the median. So if we have low sugar, we should be looking at quality, not alcohol here. Okay, and no difference. Okay, you could look at alcohol as a quality of sugar if you wanted to, but we're by and large trying to look at quality as a function of other things. Okay, then we can look at, is red better than white? An obvious thing. So we group by, and here the difference is not very great. Here, as a review, we'll plot using a bar chart. And so that is the end of our wine quality case study.